Today we're going to talk about weighted mean, which is a little bit different than mean. Actually, it's not, but it appears to be different. So we often think about it as using a slightly different formula, but it's the same. So we're still just trying to find the arithmetic average using a variable that we'll call x. And then x has a corresponding frequency, or what we often term as a weight. So each x might be accounted for more than one time. So that's why we call it a weighted mean. So we're going to start first with a table. And x could be any one variable. So today we could think of x as like the number of hours that a student studied for a test. And we can see that one student studied 4 hours, no students studied 5 hours, 2 students studied 6 hours, 1 student studied 7 hours. So we will take a look at the distribution. So looking at this little graph here, we see that the balance point, or where the mean is, will be like the fulcrum. If this were like a teeter-totter with some kids in it, like where would we put that little fulcrum so that it could balance? And so first thing we like to find is we like to find the sum of the frequencies, which we call little n, which is 4. So it looks like 4 students answered, and there's our weighted mean formula. So it's always the product of x and the frequency, or x and the weight. And then once we take the product, we sum, and then we divide by the total number, or we divide by the sum of the frequency. So same thing. And let's label this as hours, since that's our variable. And now you can see that we're taking each pair of product, and then we're summing those pairs together. And the sum is going to be 23. And after we do that, we will just divide by little n. And so it looks like 5.75 hours is the weighted mean for the students who studied.